Hello everyone, welcome to Pepcoding. Today we are going to solve a question, Merge-k-sorted linked list. So in this question we are given three sorted linked lists and we are going to merge all three linked lists into a single sorted linked list. Okay, so for this we need to write the previous code that is merging two sorted linked lists. Okay, so I'm just going to copy the code from the previous part. If you haven't watched that video, please go and view that video first. Okay, so let me take that code from there first. So this was the question, merge two sorted linked list. We just need uh, this function, merge two lists. Okay, this is here and we have to go here. Okay, so we need this function. So this is here. We have the code of merging two lists. We are going to use it. That's why I have just copied it from there. Okay, now what we have to do, we are given k sorted linked list. Okay, so let's go on the board and make an array of k sorted linked list. Like first of all, let me draw it, then I will explain you. Just suppose this is an array in which k linked lists are present. 2. The size of this array is k. Okay, just suppose, yes, the length of this array is k length. Okay, and inside this it contains the head of k linked list. Okay, and the size of these linked lists are n, like it contains n numbers of nodes. Okay, n. Okay, so let's talk about the complexity here. Okay, just suppose if you have to apply the brute force approach here, what will you do? You will just take a reference node and then you will merge two linked lists, this one and this first one. Okay, so its size is n. So I'm sorry, what is going to happen? Its size is n. Okay, so these two will be merged. Okay, after that what will happen? The size of this reference linked list is n now. Okay, and then it will be merged with this. Okay, so what will happen? This time the size is 2n. After that we move forward. If it is merged with this, the size is 3n. After that the size is 4n, and it will continue up to k. Okay, so here what will happen? It will be kn. Okay, when we are merging with the last one. So let's go and see. First of all, it was 1n, after that it was 2n, after that it was 3n, after that it was 4n, and it was up to kn. So if you take n common, what will happen? It will be 1 plus 2 plus 3 plus 4 plus 5 up to k. So what was the value? K plus 1 by 2. Okay, so we can simply see that it is nk square complexity. Okay, so let's have a look on the constraint first. Okay, what is the constraint here? Yeah, the value of k can vary from 0 to 10 to the power 5. Okay, so let's go on the board. The value of k can be 10 to the power 5 and it's the square. And the value of n, it means the size of the linked list, and that can vary from 0 to 10 to the power 3. So it can be 10 to the power 3. So the resultant output will be, for the complexity will be 10 to the power 3 into 10 to the power 10. It will be 10 to the power 13. As we know, this can't pass the test cases. As you know, like it can't pass the test cases. Okay, so we have to minimize the time complexity into n, log n, you can say. Okay, so in this case we have a k, so k log k. So we have to convert this into this k log k to pass the test cases and to pass the solution. Okay, so what we are going to do for that, let's go and see what we are going to do. Okay, so we are here. Let's again draw the array. Just suppose again the same array of size k. This is the line k length. Let me divide it. Okay, again the same scenario. Okay, it have length n and gain n. Okay, so what is going to happen for elaborating it more clearly, I'm taking the value of k as what you can say 11. It is 11, 0 1 0 1 2 3 4 5 6 7 8 9 10 11 12 13 13. Okay, this is done. So what we are going to do, we are going to break this array into two parts. Okay, so what will happen here, we have this complete array. What will happen, we will break it into two parts. Like we will get to 0 to k by 2, it means 0 to 6, a sorted linked list at one side, and the other side we will get from 7 to 13. Okay, and again we will break this, and here what will happen, 0 to 3 I will get from this point, and 4 to 6 will be from this point. Again the same thing is going to happen here also. Again we are going to break this into two parts. Okay, so from 7 to we are taking the midpoint now. Okay, so 7 plus 13 by 2, 13 7 20, and by 2 is equals to 10. So 7 to 10 this point, and 11 to 13 this point. Okay, again we are going to take midpoint of this also. So 0 3 it will be 0 1. Okay, and here it will be 2 to 3. Okay, now moving forward, it will be 0 0, and it will be 1 1, it will be 2 2, it will be 3 3. Okay, here also 4 and 6 is also going to divide into two parts. So 4 to 5 and 6 this side, it's also going to divide into two parts. Here is 4 4 no 6, and it is 5 5. Okay, here also 7 to 10. So what is going to happen here is this is also going to divide into two parts. One is from 10 plus 17 by 2 is 8. So 7 to 8 at one side, and 9 to 10 is at another side. Again this is going to divide 7 to 7 one side, and 8 to 8 one side. This is also 10 to 10 one side, and 9 to 9 one side. Okay, so this is done. Let's talk about this 11 to 13. This will also break into two parts. 13 plus 11 is equal to 24, that mid will be 12, then 11 to 12 this side, and 13 to 13 is this side. Okay, this also break into two parts, 11 and 11, and 13 and 13. Okay, so this is complete divide. Now each list have a single value here at the leafed node. Okay, so it all have single value and it's already sorted. Okay, so how much time, how much complexity it will contain, like how much complexity it will take. Okay, so it will take n, it will also take n, so this will take 2n, it will take n, it will take n, it will take 2n. So from here it will take 4n. Sorry, here it will take n, it will take n, it will also take n, it will take 2n, and 2n plus n it is 3n, and 4 plus 3 it is 7n. Okay, and the same thing here also 7n. So the complete complexity that is going to be, it is 14n. Okay, now let's see what will the height of this tree. Okay, So every time we are going to divide it into two parts. Okay, so let's see. So whenever we divide this into two parts, then again two parts until we get one. So the height will be log to the base 2 n. Here the length is k, so log to the base 2 the log k. Okay, so let's see how it is. Okay, we are here. So we can see that the first time the length was k. After that the length became k by 2. After that the length became k by 4, and at last it became 1. Okay, so we can see a GP here. Okay, where the starting point is k and the ratio is 1 by 2. Okay, so what will be the AP, like the last term, like the pth term, what we can say? So AP will be equals to a naught r minus 1, not r minus 1. Let me raise this, a mistake. Yeah, r to the power p minus 1. Okay, this is the formula for GP's term. Okay, now we move forward. After this, let's see, if we have to find how many terms it have, the last value is 1, so it will be 1, a0 is k, and the value of r is 1 by 2, and the value is p minus 1. Okay, so let's solve this. 2 to the power p minus 1 equals to k. Okay, we need some more page here. So we will take log both sides. Log 2p minus 1 is equal to log k. After that, what will happen? This side, log 2 p minus 1. Okay, p minus 1 is equal to log k, and p is equals to log k plus 1, and b is 2 here. Okay, this is the value of p. Now what do we want to do with this strategy, with this divide and conquer strategy? Okay, let me tell you. Let's go to some clean place here. Okay, we are here. What will be the time complexity here? So we have divided it into two half part now. So what will happen? One side they will merge half of the size of list, and they will merge half of the side of the list. So I will get two merged lists, and then what I will do, I will just merge these two lists. Okay, so let's write the time complexity for this. T of n by 2 plus T of n by 2, and then we have here n times of k. Okay, let's write some code first, then it will be more clear. Okay, so let's go on the board and write some code. So previously we have written this merge two lists. Okay, I'm just going to copy this here and make a function merge k list. And what we need here, we need here the list and one left side of the index and the right side of the index. Okay, this is done. So remove this null part. So first of all, what we have to do, if our li is equals to ri, it means we are divided into the one list only. The one list only is left. So if it is that, we will simply return the lists of ri. Okay, this is done. Now what we are going to do, if this is not true, so we are going to take the midpoint first. So and mid, sorry, if so, what will be the mid? Mid is li plus ri by 2 by 2. Okay, this is done. Now what we are going to do, we are going to make the calls. for half of the list and a half of the list. Okay, so let's go and write here to make some call. Okay, so the left list node is here for the sorted left list. Okay, we will make call here merge k list. This is done. We will pass the list here and the starting point and the mid. In the right side we will send from mid plus 1 to the last index. Okay, so again one more list sorted r lists. It will be equals to merge k list. Inside this we'll pass list comma mid plus 1 comma ri. Okay, this is done. Now what it will return? It will return as merged half left of the part half left of the linked list and half right of the linked list. What I have to do, I just have to merge these two linked lists. Okay, so I will call merge two lists. So what I will return from here, I will return merge two lists. Inside this, what we are going to do, we are going to send the sorted list, sorted L list and sorted R list. Okay, this is done. Now let's go on the below function. Here what we are going to do, here we have received a list, so we have to make a call for this function from here. Before that we have to take care of one more condition also. If the li is greater than ri, so we have to do nothing, we just have to return null. Okay, if the left index is greater than right index, it means it crossed the right index. Okay, so we just return null from that point. So we are here, what we are going to do here, so if the length of the list is 0, so we have to return null. Okay, so if the length of the lists dot length is equals to 0, it means we have to return null, and if it is not null, we just have to make call. So what do you have to return from here? We have to return from here merge k list. I will send the list and 0, and the length of the we have to calculate the last index, that is length of the list minus 1, list dot length minus 1. Okay, this is done. I think this is all just code. Now let's check the complexity for this. Yes, where is the crop it? Yeah, it's here. So I'm just going to crop this and take it into the board where it is. Okay, it is not here. It is here. Let me take this to this point. Okay, now we are here. Now let's talk about the complexity that we were talking earlier. So t of n is equals to t of n by 2 plus t of n by 2 plus k of n by 2 plus k of n by 2. Okay, so eventually this is going to be sorry, 2t n by 2 plus kn. Okay, this will be the t of n. This will be the total time complexity. Okay, so now let's see what will the t of n by 2 will be equal to twice of we have to just put the value of n by 2 here. So twice of t n by 4, okay, n by 4 plus k of n by 2. Okay, now let's move forward and see. Actually, I think this will be, so let's move forward. N by 4 equals to twice of t n by 8 plus k n by 4. Okay, so it will go on, it will go on, it will go on, and we have some result here. Okay, so just suppose if we multiply this by 2, so it will be 2 square, it will be 2. Again, I multiply this by 2, so it will happen 2t, then it will be 2 square, 2 square, okay, by 2 square. So it will be 2 square, it will be not just 2 square, it will be 2 cube, I think. Yes, it will be 2 cube and it will be 2 square. Okay, and the same thing will go on. Now let's see what will be the result for this. Now we can see we can replace this part with this. Exactly, they both are the same thing. So first of all, I'm just going to add all this all these statements. Okay, so what we will get here, let me write the last line. Okay, so this will be 2 to the power p, 2 to the power 1, 2 to of 1 is equals to 2 to the power 2, 2, 3, and then it will be, I think, p minus 1. From the relation we got it, and then it will be t of 0 plus 2 to the power p n by 2 to the power p. Okay, we have k also, k n by 2 to the power p. So what we'll get a result, like it will be all cut by this, so it will be by this, it will be by this, and then this all will be cut down again, again. Okay, so what we will get here, so t of n will be equals to 2 to the power p minus 1, actually t to the 0 plus it will be added p times, so twice of, not twice, it is let me erase this is all cut down, so erase this. Okay, so kn will be summed how many times, p times, so k will be out here from 1 to p times, n is out here and k will be added p times. Okay, so let's make some space here. Okay, now let's see, let me erase this. We have added nk p times. Okay, so what will happen here, actually nk will be here and the one, like the, it will be summation p times. Okay, so now what will the value of t of n, so we have, actually we have got the value of p from here. Let me take that. Yeah, it is here. The value of p is log 2k plus 1. Okay, so here twice of log 2k plus 1. Okay, this was plus 1 by mistakenly I write it. Okay, so k plus 1 plus 1 and t to the power t of o plus nk, it will summation from 1. The value of p is log 2k plus 1, so log 2k plus 1. Okay, so what will be the result of this, let's write it. So t of n equals to twice of log 2k plus 2. Actually we can write this plus 2 into 2 to the power 2. So let me erase this. We can write this 2 to the power 2. Okay, this is here into 2 to the power 0 plus nk, and it will give us the value log 2 k plus 1. Okay, this is done. Now what we have to do, actually I think we have done some mistake. This was in the term of k, because we have k sorted linked list, k by 2, k by 4. Okay, this was all k, this was all k. By mistakenly we have done in the term of n, but it is all k. Okay, just remember it, it is all k. Here also it is k. Okay, okay, so it was all k. This also, this also, here also, here also. Okay, so I hope you got this. Now let's move forward. So here what will happen, the t of k will be equals to, if we write this as k, so what will happen here, just see, we will conclude this and make it different, so it will be ok plus, this will multiply it, so nk log base 2k plus nk. Okay, if we make 4 make nk as n dash, just suppose, so what will happen, t of k will be equals to 4k plus n dash log base 2k plus n dash. Okay, did you get that? So now if we talk in terms of big O, what will happen? Let me write it here. T of k in term of big O, it will be n dash log 2k, because as comparison to n dash log 2k, these two terms are very small. Okay, now let's move forward. Okay, so now if we talk about this, so it will be nk log base 2k. Okay, now let's go and see what will the time complexity according to our constraint now. So the value of n can vary. Let's go NCR constraint here. Here is the constraint. K can vary from 0 to 10 to the power 5 and size is 1000. Okay, so let's go. The value of n can be 10 to the power 3. The value of k can be 10 to the power 5. Log base 2, the value of k is 10 to the power 5. Okay, that is right. We have seen, yeah, it is right. Okay, so now let's calculate the time complexity. Let's make more space. Now, right, it will be 10 to the power 8, and if we calculate this, what we will get? It will be 5 into log 2 10. So what will the value of this? 10 to the power 8 into 5 by, it will be 0 0.321, something like this. Okay, so see how much complexity is reduced in this solution. Okay, so here we see, let me, here what we have, let me show you where we were. Here we have the time complexity of 10 to the power 13. Okay, and now it is approximate, like we are talking in the terms of big O, it is approximate 10 to the power 8. Okay, so actually we have also ignored, here we have ignored the small values like nk and 4k, so it will be approximate value, that's why we are talking about in the case of big O. Okay, I hope now let's go and run this code before going. Okay, so we are here, now let's run this code. Okay, I think we have some error here, let's resolve this first. Okay, let me make it on the full screen, then we'll see. Okay, we lost where it is. Yeah, we have an error like L1. Okay, some typing mistake here, it is li, not L1. Okay, this is done. Now let's run it again. I think yeah, I must have some typing mistake. This cannot find symbol. This not sorted or list is equal to Merge-k-list. Okay, again the typing mistake. Okay, it's in the line number 44. Yeah, Merge-k-list. Okay, let's see any other error. Okay, now let's run it. It is accepted. Now let's submit it. It is taking some time. Yeah, correct, 10 by 10. I hope you have learned something. Please like and share the video and subscribe the channel. Thank you so much.